So, if you've got to write down a differential equation satisfied by v, what this tells us is that the rate of decrease of v is proportional to the value of v. So dv by dt, that represents the rate of change of v. So differentiating it would give you the rate of change of v. Now that is proportional in this case to the value of v. Now because it's a decrease, we're going to put minus, and if you remember from proportion at GCSE, there was always a constant there, so we use a for the constant. You can use whatever letter you want for the constant, but you could see later on in the question there's going to be an a involved, so we always go with a as the proportion, as the constant in this case. That is your first mark. That is actually part A in this quick case. Just write down a differential equation satisfied by v. That is a differential equation satisfied by v. So the rate of change of v is proportional to v, and obviously because it's a decrease we put a minus. If it wasn't a decrease we just write a v there. Sometimes they will state that as a specific question, write down the equation. Sometimes they won't, they will just go to part B and you need to write that bit down anyway. You'll still get a mark for it, it might just not be its own part A. Now the method for part B now is again pretty consistent every time. They're going to give you some values, so they're going to give you some values for v and t, and they're going to ask you to show something, and then later on they'll ask you to use your equation. The method for this is called something separating the variables. So what we do is we collect all the v's on one side and everything else on the other side, and we integrate both sides. So we're going to separate the variables, so we're going to have dv divided by v on that side is equal to minus a dt on the right hand side. So we're separating them, so we've got all the v's together, or whatever letter this might be, on one side, and then we integrate both sides of that equation. If I integrate what is effectively 1 over v, I'm going to get the log of v on that side, and then on the right hand side we're integrating with respect to t now, so you can think of this as minus a t with a power of 0, so it's going to go up to the power of t1, and we don't need to divide by 1 because obviously it's 1. There is, because we don't have any limits on this, there is a constant we need to think about, so we're just going to put that constant on that side. It doesn't matter really which side you put it, but we just, for ease of later on, we're going to put it on that side. dt is just telling us what we're integrating with respect to. What we're really integrating is just the minus a. So if you think of minus a as being minus a t to the power of 0, because we're in terms of t here, that's going to go up to 1, so that's where minus a t comes from. Remember, this dt is just part of the integral sign, really, telling you they're integrating. Because we're integrating with respect to t here, so there isn't a t there, so we think of it as t with a power of 0. So when integrate, I add 1 to the power and divide by the new, this becomes minus at to the power of 1 divided by 1, which obviously we can just write as minus at. Once you've done that, you need to try and make your equation look like the one they want. So they want v equals 1200 e to the power of minus at. They haven't got log of v there, so we need to get rid of the log. What do I do to get rid of the log? So I'm going to use e, so this becomes e to the minus at plus c. Now at this point, there's a little kind of trick that we use to take into account the fact that there's actually a constant within this here. If I was to write this out as e to the power of minus at times by e to the power of c, this is the same as that. Do we agree? If we times things, we just add the powers. Now e to the power of c, c is a constant, e is a constant. So that in itself is just a constant value. We don't know what constant value it is, but it is a constant value. So we're going to refer that part of it as just capital A to represent a constant. And we always use A for some reason. I don't actually know why, but it's always A. And then it just becomes A e to the power of minus at. So we've just taken the constant, we've grouped together these constants into one capital A. We're nearly up to the point it wants. So the point it wants us to get this, and it's told us that v is 1200 when t is 0. So we're going to use the equation we've just got. So we're going to say v is 1200 like it says in the question, and t is 0. So we're just going to substitute those values in. 1200 is equal to a times by e to the power of 0 minus 0. What's anything to the power of 0? 1. So this is going to be 1 and then we're going to find out that 1200 is equal to a. So then we can just rewrite that as v equals 1200 e to the power of minus a t. Technically, I suppose if you want, you should write minus 0, a0 here, because the a is still there, but obviously 0 times anything is 0. E to the power of 0 then is 1. And we've now proved what they wanted, which was part B, was to get that constant. Part C, in this example, says that when t is 5, v is 5,400, and it asks you to find the value of a correct to 3 decimal places. So we're going to use this fact now to put it into the equation. So we're going to say that 5,400 is equal to 1,200 e to the power of minus a, or minus 5a. We could write that as minus a times 5. So we end up with 5,400 is equal to 1,200 e to the power of minus 5a. And then we're just going to use log rules, indices rules, etc. to split that all the way back, so we just end up with a. So we can divide by 1200 to start with. So we've got 5,400 divided by 1200 equals e to the power of minus 5a. How am I going to get rid of the e? So then I'm going to do the log of 5,400 divided by 1200 equals now just minus 5a. And then what am I going to do on the very last line? So then I'm going to say that, we'll write it as minus a fifth times by the log of 5,400 divided by 1200 equals a, and obviously you can just plug that into your calculator and get a value for a. I've run out of space, so I'm going to do that bit, but you can.